So, good morning everyone. I'm Samuel Boudet. I'm from France, from Catholic University of Lille. And I'm gonna present you a project we have to build a dataset for an AI competition for recognizing every patterns on fetal heart rate. So false signals, baseline, variability, deceleration, type of deceleration, contraction, etc. If you have a laptop computer, you can have a look already on the address where the label website is already online, and everyone can join it if they want. It doesn't work on mobile. So before starting, I will start by presenting our project. So we have done an e-learning website in France, which is called ERCF. We have done a research central of monitoring, which is used to record our recordings in our hospitals, and we hope one day to put it on open source. We have a dataset of about 20,000 recordings. We have recording from 2011. And more of all, we have developed a toolbox, which is unfortunately on MATLAB because we started with MATLAB, now it's more Python. But on top of a viewer, you can have a model we have developed to recognize maternal heart rate interference, and we have put even the dataset on it, and the model is open source. And we have another method to detect baseline, acceleration, deceleration, and we have put also the dataset online. So to make the data challenge, we wanted to generalize what we already done with the two previous projects, but to reassemble in one only problem. And we wanted to integrate also the patterns we don't really care so far because we thought it was simpler, but if we look closely, this is not simpler, this is not so simple, at least to be at expert level. So we had a contraction, variability, deceleration types, and sinusoidal patterns on the list of patterns we want to detect. The idea is that for an AI, if you train an AI to recognize each pattern individually, you may be less performant compared to an AI which recognizes all patterns in the same time because there is interdependence between patterns. For AI researchers, I think it would be a very interesting problem because if we formulate the problem like that, there is a lot of long-term features which have to be detected, and it may be required to use attention mechanism, and this kind of be challenging for an AI researchers. So the application of the AI would be first direct. It could be displayed on monitoring centers. It could provide some alarm. For example, if there is a false signal or maternal heart rate interference, there is an alarm to put back the sensor. Or if there is abnormal pattern, there could be alarms. The second application will be to the sangual of the fascia to detect epoxy. So it will make the feature extraction. We thought maybe the feature extraction may be emergent from the epoxy detection, but we think it's not so simple, and having a labeled dataset in this sense may be better. And the last application is for doing further research to have a quantification of each fatal threat patterns, and we can make studies to measure the effect of a tocolytic treatment, for example. So we have a project to launch a data challenge. The idea is that creating such a data set, it's so much work that we don't want to keep it for ourselves and just do one method and keep the data set. So we want to share it to maximize the data set utility. We want to promote open science, so we put data online and we encourage open source methods to claim the cash prize if we manage to have a budget. Most of all, there is a lot of flawed study in the literature which has a non-rigorous training test procedure, which doesn't fully understand clinical context. And we want to, for non-specialists, to have an entry for the FHR analysis problems and to be sure that they do things correctly and beneficially for the patient. So we have developed a complicated web interface to broaden the annotation community to the entire world. There is a lot of annotation to do. It's broken down in 6 categories. First, we have to analyze the TOCO, then the maternal abstract, just to annotate false or true signals. Then there is either the Doppler sensor of if there is an internal ECG sensor, we have to annotate false and true or true signals. Then we have to realize the morphological analysis. So it consists on drawing the baseline and to say where are deceleration and which type of deceleration. Same for accelerations. And then we analyze the variability. It can be normal, reduced, absent. There can be a sinusoidal pattern and increased variability. The idea is that on those 6 categories, a time sample can be only on one category. So if it is a classification problem, but we have 6 classification problems for each time sample. The idea also is not to annotate the entire data, the entire recording. We have to annotate only when it's interesting. If it's too easy, it's not interesting for the AI. So we expected, for in 1 hour recording, there is only 20% of labeling. If there is no annotation, it means either that the expert do not know, or if it's not interesting for the AI to train. And for deceleration, acceleration, etc., we can say expert can say that it is not sure of which type is the deceleration, or he doesn't want to input it, and it will be taken in the cost function at the end. There is a subtlety on the baseline, so we wanted to do only a classification problem. So there is a duality in the definition on the baseline and baseline periods. The baseline periods are periods on which the fatal heart rate oscillates around the baseline, and the baseline is then the average on a sliding windows of the baseline during the baseline period. So we use the second definition in order to have a problem only of classification. And during the annotation, to be sure that it is coherent, we draw the baseline automatically doing a median on 1 minute window and doing linear interpolation between baseline periods. So we have worked a lot on the interface to reduce the time of annotation, because it could be very long if we don't do that. We have put a lot of keyboard shortcuts and mouse manipulation. We can really speed up the annotation. Globally, if you want to annotate 2 hours recording, it can take 10 to 15 minutes. But in general, we ask only 20% of annotation, so we can count 5 minutes to annotate only interesting part. We have also worked on every definition of each period. Expert have to select. We are based on the FIGO 2015 recommendation, but we have done a lot of nuances, since it's not only the aim to help the clinic, but it's the aim for an AI, and sometimes there is differences in definition. For example, for the baseline, we cannot just satisfy a 10-minute value. We have to draw a mobile baseline, so there is some case of differences. This is an example of 3 times speed up annotation process. You click on the beginning and end of each contraction first. Then you fill the period saying which is baseline TOCO. Here you analyze the violet channel, the maternal heart rate channel, just to say it's always 2 signals. Here on the fetal heart rate, we recognize some maternal interference, so the expert analyzes it. Then he'll fill the remaining, saying it's 2 signals. Then you annotate deceleration. There is no deceleration, and it's always baseline. And it annotates the variability. So we see that half an hour was analyzed in 3 minutes. It can be a bit more complicated, but not necessarily. The idea is that each recording is analyzed by only one expert, but another expert will review the analysis. He can validate, or he can correct and put comments. If there is correction, the first expert can either accept the reviewer correction, cancel his annotation, or he can refuse the correction and re-annotate. But in this case, the review process starts again with another reviewer. We will start by completing the dataset we already put online for false signals and baseline, and we complete the annotation. And the aim after it will be to add a recording with rare patterns. For example, we have very low sinusoidal patterns, and we have to complete the dataset with those patterns. At the end, the AI problem we have in input the CTG recording, the sub-Saharan origin, yes or no, because it changed the variability. The gestational age also to say if the variability is normal or the reduced variability is normal or not. And if the recording is antepartum, labor, or for delivery, of a second stage of delivery. The output expected is for each time sample, the probability of being in each of periods, the 6 categories. Sorry, the 6th one. So there is 6 independent classification problem, enfin, not really independent, but sorry, excuse me. Excuse me. And the final evaluation matrix would be the percentage of well annotated, but with weight on errors. For example, normal variability and pseudo-sinusoidal variability does not have very importance if you mistake between this. But between pseudo-sinusoidal pattern and sinusoidal pattern, this is a bigger error. We plan to propose a data augmentation since it's a bit complicated. There is kind of lot of data augmentation we can do for the training dataset. Sometimes it may change the label. For example, we can create artificial false signals on each channel. And for testing, it is important to test either the ability to analyze the whole recording or to analyze in real time. So we truncate the end of recording and we evaluate the real-time performance also. So our plans to finish this project, we have a project to do 2 competitions. The first one in the next year with a small dataset which will be the fastest possible. It will be for science. There will no be cash prize. And the aim is after to realize a bigger dataset and in 26 and to have a funding for a cash prize. And maybe we could do the award ceremony in the next PAM Congress if if we have the opportunity. For now, we have done the interface of annotation and we do the final test. The idea is to have paper to 2 papers to present the competition each time. And we are looking for contribution. We are looking for a person to join the annotation committee. And we are looking also for persons which could send a recording for our pattern or partially annotated pattern, annotated recording if someone have. So contributor will be invited to be co-author of each paper of the competition. So you can have already the look on the annotation interface now. Thank you for your attention. If you have questions.